All right, section 11.3, general angles and radian measures. So we're going to look at converting between radians and degrees and drawing and calculating different kinds of angles. So first of all, radian is just another way to measure angles. It's always in terms of pi. And right here is kind of the key piece. To be able to convert measures in radians, you got to multiply by pi over 180. If you want to go from radians to degrees, you got to multiply by 180 over pi. So if we take a look here, convert 320 to radians. So if you're not sure which one you're trying to use, if you want to get pi in your answer, which is what radians always has, you multiply by the 180, or pi over 180. I was going to write it over 1 here. So the whole idea here is to multiply and reduce if possible. There we go. So let's go ahead and reduce. So 320 over 1, pi over 180. We can cross cancel here a little bit. 320 and 180. Let's see, they're both divisible by 10, so we could go 32 and 18. And then from there, we could divide them both by 2, so it would be 16 over 9. So now if you multiply the numerator, 16 times pi is 16 pi over the denominator. 1 times 9 is 9, and you can't reduce anymore, so that's it. So 320 degrees would be 16 pi over 9 radians. Now if you want to go the other way, from radians to degrees, our goal is to get rid of the pi. So now this time we're going to take negative 5 pi over 12 multiplied by 180 over pi, because our pi in the denominator will cancel the pi in the numerator, so then we're going to get rid of pi. And same thing, you want to reduce as much as possible. I mean, you could multiply across and then reduce, but I like to do it before. So let's see, we can take 12 and 180, we can divide them both by 12. So 12 divided by 12 is 1, 180 divided by 12 is 15. The pi is canceled, so if I multiply across the top, negative 5 times 15 is negative 75, and everything else is gone, so negative 5 pi over 12 radians is negative 75 degrees. All right, so standard position. So here's how we draw every angle. You always start from the positive x-axis here. This is where you're going to start from. We're going to call that our initial side. And then we're going to draw our angles. Now, positive angles, you always go counterclockwise. Negative angles, you go clockwise. But no matter which way you go, I'll go like this. No matter which way you go, the other side is called the terminal side. So we have our initial side, which is the positive x-axis. We have our terminal side, which is wherever our angle is going. I talked about the movement. So this, for example, could be like a 45-degree angle. And then if you want to go negative, you'd go the other way. Coterminal angles, we have a lot of vocabulary here. These are angles in the same position that have the same terminal side. So for example, let's go with, I don't know, something pretty easy to work with, like a 30-degree angle. So to draw a 30-degree angle, by the way, this is 0, 90, 180, 270, and if you come all the way back around, this would also be 360. So if you want to draw a 30-degree angle, it's going to be somewhere out here. We'll call that a 30-degree angle. So an angle that would be coterminal is coterminal would be an angle with the same terminal side, but obviously not the exact same angle. So the easiest way to do this is just start from your angle, or to start and go all the way around 360 degrees and then end back at your terminal side. So we went 360 plus another 30 for a total of 390 degrees. So 30 and 390 would be coterminal. And again, here's the key. You can go 360 positively, or I could have just gone the other way, subtracted 360. But these are angles. Coterminal angles are angles that have the same terminal side but different angle measures. Here's a chart you can look at if you want to some examples like 30 degrees here, like we said. If I go all the way around 390, I could add another 360 and end right here. This is only showing positive. You could also work it backwards if you'd like. So it says draw an angle with the given measure in standard position, and then we'll talk about the quadrants. So we have a negative 120 degree angle. Again, let me remind you, this is 0, 90, 180, and 270. And then again, if you come back around, 360. So a negative 120 degree angle, we're going to start here. Oh man, we're going to start at the positive x-axis, which is right here, and we're going backwards. So this would be negative 90, negative 120 would be over here, somewhere between 180 and 270. So what quadrant does that lie in? Quadrant, we'll call this quadrant 3. Because we go 1, 2, 3, and 4. Quadrant 1, 2, 3, 4, we count counterclockwise. So a 400 degree angle is going to look something like this. So you're going to start at the positive x-axis. We go around 360 plus another 40 degrees. So somewhere between that 0 and 90 range. We would call that a 400 degree angle. Now you do need that little arrow thing that I drew, this little curly thing if you go past 360, just to show me you're going past 360. Otherwise it'll look like just a 40 degree angle. And that falls into quadrant 1. And this is going to be important here when we start talking trig functions and angle measures in, I think it's 2 sections. So then we have 2 pi over 9, so that's in radians, of course, so we need to convert that to degrees first. So we'll go 2 pi over 9 times 180 over pi. The pi's will cancel. If you can, you should cross-reduce, so 9 and 180, we can divide them both by 9, so we get 1 and 20. Then if you multiply, 2 times 20 would be 40 degrees, so we're really just trying to draw a 40 degree angle. So we'll start at the positive x-axis, we'll go up 40 degrees, and again that falls into quadrant 1. So find one positive, one negative angle that are coterminal with the following. So I'll draw the 100 degree angle for you. So that is going to be somewhere here between 90 and 180, and we would do this to show it's 100 degrees. Now if I want to find a coterminal positive angle, I'm going to take 100 plus 360, and I will end up with 460. And if I want to go the other way, I would take 100 minus 360, and I'll end up with negative 260. So those will both be coterminal. We're just adding a full circle and taking away a full circle. Now 575, so here's how we would draw this. Start here, we go around once, there's 360. And then if you count the leftovers, it takes you somewhere between 180 and 270. So it's a 575 degree angle. So to find coterminal angles, take 575 plus 360. And we end up with 935 degrees. And you can take 575 minus 360. Now that is 215, which is not a negative angle, so we got to subtract 360 again. Got to subtract another full rotation, and we end up with negative 145 degrees if you subtract that out again. Let's just clean that up. All right. And then there's just a couple more here if you want to convert between radians and degrees again. So negative 140 degrees means I need to multiply by pi over 180 because I want pi in my answer. So I'll put this over 1. And then again, reduce if you can. We can divide these both by 20. So it would be negative 7 and 9. So negative 7 pi over 9 if you multiply across. And the last example here, convert 3 pi over 4 radians to degrees, so 3 pi over 4. Now this time I'm multiplying by 180 over pi, because that's going to cancel out the pi's. Degrees don't have pi in the result. And then reduce if you can, so we can divide 4 by 4 and 180 by 4. And if you multiply across, 3 times 45 is 135 degrees. So there you go, section 11.3, general angle measures and radians.